And third up today is a fairly unusual internal resistance question. So have a go at this one. The last part is worth 2 marks. Okay, so the first job is of course to draw out the circuit diagram. We've got 4 cells with 1.5 volts of EMF each. So I've just drawn it all together. So 4 lots of 1.5, 6 volts EMF, and 4 lots of the internal resistance is 3.6 ohms there. And there's our lamp with 18 ohms. Okay, so if the lamp is working properly, if it's to normal brightness, then we're given these numbers here. So we want to work out what the current is. What's the current through the bulb to make it light at normal brightness? So I've used various ways you could do it. You could use the power formula if you wanted, but I've gone for Ohm's law there. So I is V over R. So normal brightness, that's the voltage, that's the resistance, so we get 1/3 of an amp. Okay, but what actually is the current in the circuit? Well, let's use the same formula, I equals V over R. So the current in the total circuit is going to be the PD across the total circuit. And that, remember, Kirchhoff's second law, total PD is equal to total EMF. So there's our 6. And this is the total resistance of the circuit. So there we go. And that gives us only 0.28 amps. So that means it's not going to light to normal brightness. We needed 1/3 of an amp. So the next part asks, how many cells do we need in order to get 1/3 of an amp? And there's various ways you can do it. And if you do it by trial and error, then you get both marks. That's a totally acceptable way of doing it. But this is the algebraic way. We have 1.5 volts for every cell. So if we have n cells, that's our EMF. And if we have n cells, that's the total internal resistance. Bulb hasn't changed. And then we do exactly the same thing, or various ways you could do it here. If we do exactly the same thing, then we're using the same formula. We're saying we need 1/3 of an amp in the circuit. The total PD across the circuit is equal to the total EMF, and the total resistance of the circuit is now that. An alternative way to do it would be to use the internal resistance formula. And so then we've got, there's the EMF. We need across the lamp 6 volts, and then we need a current of 1/3 of an amp, and the internal resistance of the cell is that. Whichever way you do it, you'll get n equals 5.